Hello everyone and welcome. Today we're going to be having a look at the Diels Alder reaction and mechanism. So let's have a look. So it's a cyclo-addition reaction between a diene and an alkene. So there's our diene and there's our alkene. When we talk about a Diels Alder reaction, like I say, it's a cyclo-addition, so we're going to be making something cyclic. These have special names. This one is called a diene. And this one is called a dienophile because it is attracted to dienes. It likes dienes, dienophile. So let's have a look at the reaction mechanism. So as you can see, we have our diene here with one double bond and two double bond. So the first step is that this double bond will form a new double bond there. This will form a sigma bond. And this will also form a sigma bond. And now I sort of like to illustrate these new bonds forming. It really helps if you can't sort of visualise it. So there's going to be a new bond from here to here, and from here to here. So what we're going to form is our six-membered ring. And I'll draw the new bonds in green. Just like that. And we have our alkene there, which was formed by this. So that's the general reaction mechanism. That's the most general reaction of the Diels Alder. We form a six-membered ring from a diene and a dienophile. So let's have a look at some more examples. So again, I'll just start out with a diene, and we'll react it with an alkene. Just like that. What products are we going to get from this reaction? Well, the mechanism is the exact same. So we're going to form our new pi bond, sigma bond, sigma bond. I'll illustrate the new bonds once again. Just like that. So what we're going to form a six-membered ring again. And our double bond there. And if we count the carbons, 1, 2, 3, 4, 5, and 6, we had a methyl on number 2 and a CN group on number 6. Just like that. Let's have a look at another one. I'm just going to show this one that you can do it numerically if it helps. So let's number the carbons. So 1, 2, 3, 4, 5, and 6. So we've got a new bond forming between 1 and 6. 1 and 6. And we have a new bond forming between 4 and 5. And the reaction mechanism shows this. So this bond forms our double bond here. This one forms the bond between 4 and 5, and this one forms the bond between 1 and 6. We had an NO2 on number 1, and an OH on number 6. Just like that. Let's have a do another one. What we're going to get now. Again, the mechanism is just the same. I'll illustrate the bonds again. Bonds forming between these carbons. I'll actually draw the bonds in green again. Oops. Just like that. See, it's a pretty general reaction mechanism. We're forming two bonds and a new pi bond. So 2 sigma bonds form, 2 sigma, 1 pi bond forms. Let's have a look at another example. Now this may cause some alarm. As you can see, it does look daunting as we have a cyclodiene now. We have an extra carbon connected to our diene. Don't be scared by it, it's the exact same reaction mechanism. So we're going to form our bond there, a new bond here, a new bond up here. Just like that, our new bond there. Now, let's number the carbons. So we have 1, 2, 3, 4. Between carbons 1 and 4, between here and here, there is an extra carbon group. Just there, just an extra carbon. If we number our carbons on this molecule, 1, 2, 3, 4, we have a carbon missing. So let's just draw it in. Just like that. So this carbon here is this carbon here in the yellow box. I hope that makes sense. It's pretty confusing. It's not the easiest to understand, to get your head around if you can't see it. But this carbon here is this carbon here. It's sort of been lifted up, like folded upwards. Let's do one more. This one is probably my favourite example. It's a really big molecule. Again, it does look confusing because there's 2 double bonds in this molecule. You could call that a diene, and it is a diene. So what's going to happen? Well, the same's going to happen. It's going to form the same reaction mechanism. But because there's 2 double bonds in this molecule, and they're both equally reactive, it's going to do the exact same thing from the other side. It has no preference. Forming a bond between here, a new bond there, a new bond there, and a new bond there. So I'll draw these new bonds in green again. Just like that. So that's the Diels-Alder reaction mechanism, guys. I hope that helped. I hope it wasn't too difficult. If you have any questions, please let me know. And thank you for watching.